Alright. So 1.2, evaluate and simplify.
Oh, so neat.
Gives that a workout.
Algebraic expression. So like I said, you should already have the notes written down for this. If you haven't, then I suggest you go watch the video from that. Because we're basically just going to run through examples today, okay? Just remember that this section we're talking about like order of operations being a big thing. We're looking a lot at exponents, simplifying, things like that. Might look a little bit at word problems, but probably not a ton. So let's start with number 4. So these are just saying to evaluate the power. So 2 cubed is equal to what? 8. So 2 times 2 times 2. Negative 5 squared is equal to what?
25. I was going to say that, but I know it's negative 20.
It's negative 25. Okay? The difference here is the squared is only touching the 5. Okay?
Oh.
If it looks like this,
So it is 5.
then the negative is also being squared, and then this would be positive 25. Okay? One other scenario you could see on occasion, you could have something that looks like this. Okay? Which means that inside it's positive, but because of the negative outside, you've got that. Okay?
Can you like have like a negative exponent?
Yes. But I don't think we do that in this section. I think that comes later.
So what if it was like negative like that, but it was cubed? Would it the answer still be a negative, or would it change the function?
If this was cubed,
No,
this one,
the other one.
this one.
Yeah. If that was cubed, would it?
So to go here for just a second, if this was cubed, if this, the negative 5 in parentheses squared, if that was cubed instead, negative times a negative times a negative is negative. Okay, so basically what's happening is you're taking this negative sign and doing whatever the power is, and then you're doing it to the number as well. So that would still be negative. So then if you came down here and you had the negative outside, then the negative times the negative is make it positive. So, and I'll show one just like that here in the next one I'm going to do actually. So if you had negative 8 cubed, okay, now I'm not expecting y'all to know 8 cubed off the top of your head.
What?
8 cubed.
502.
You're close.
Negative.
Carry a 1. It's 512.
Yeah.
I had it in my head, but I didn't.
Okay, 512, but remember this negative, it's just out there, nothing was happening to it. Okay, so if we had this, okay, does that change anything? No. It's still negative 512. So if it's raised to an odd power, okay, 3, 5, 7, 9, whatever, it's not changing anything. The signs are going to stay the same, okay? But if it's an even power, like 2, 4, 6, 8, things like that, then we have this scenario from number 8 here where the sign will go away if it's in the parentheses and stuff like that. Okay, now like you asked, if you had this scenario here, okay, that's negative 512 times the negative, so then this is just positive 512. Okay. And that is a very common mistake that I see made. With these ones, obviously, it's not really, like, I mean, it's going to hurt you because obviously it's giving you a wrong answer, but when you get to problems where you're combining everything, if you're not paying attention to how the negatives are in there and stuff, it can really throw off your final answer when you're like solving equations and stuff. Let's see. All right, so 12 negative 3 squared. What would that be?
9.
Okay, 9. It's being squared, so that negative sign is going away. And let's see. 14. Negative 2 to the 8th. Is this going to be positive or negative?
Positive.
Okay, it's going to be
Five
positive.
times 8, 12.
No.
Okay, I was just guessing.
Half of that.
256.
256. Okay, some of these, like 8 cubed is not something I necessarily would expect you to know, so if you need to like do that on your calculator for the purpose of like doing your homework and stuff, that's fine. On a quiz and a test, since you won't have your calculator for this particular chapter, I won't put something on there that you can't multiply, that you like shouldn't be something that you know. I usually say like several, like 2 cubed, 3 cubed, like you should be able to figure those out. Even really like 3 to the 4th you should be able to figure out. But as we get up higher, like 7 cubed, stuff like that, I'm not expecting you to just know that off the top of your head. Things like that.
There's people that do though.
If I use them enough, like I do, but like there'll be like I think it was like Algebra 1 like 2 years ago when I was teaching it, for some reason 7 cubed kept coming up, and I told them, I said, okay, at this point I expect you to know what it is, because I was like, we've used it like 20 times in class, you should just know it, you know. But it, yeah, I usually don't pick like the super hard ones if I'm not giving you a calculator to be able to multiply it, because it just takes too long. Okay, so the next set of problems in here says to evaluate the expression for the given value of the variable. So we have something like 18. It says, let's see, 6h divided by 2 plus h when h is equal to 4. Okay, so in this, remember, order of operations is critical, okay? All you have to do here is plug in the value for h and then use order of operations. So I plug in 4 everywhere I see an h. Okay, and I like to put parentheses around it because if it were negative, okay, then we have to pay attention to the signs on it and make sure that it doesn't look like let's say this was negative 4. If I didn't put the parentheses, it might look like 6 minus 4. Okay, and that might get confusing when I'm really supposed to be doing 6 times negative 4. Okay, obviously this one's positive, so it's not as big of a deal, but out of habit, I just like to go ahead and throw parentheses around all of them. Not something I'm going to like take off for, but it will help you to eliminate mistakes and stuff. So 6 times 4 is what? 24. I'm just going to go ahead and do this. Divided by 2, 12 plus 4, 16. Okay, so that one, order of operations, it was already in order for us, okay? If it hadn't been, then obviously we would have done that a little differently. But that's all you have to do for that. Purple went away. Let's see. All right, 22. I'm going to have you guys try this one on your own, and then we'll go over it. N cubed minus 4n plus 10 when n is equal to negative 3. So take a minute and try this one. And then we'll go over it. we have an answer?
Negative.
All right, I've heard several different answers, so let's plug it in and see what happens. All right, so we've got negative 3 cubed minus 4 times negative 3 plus 10. So order of operations says I need to do what first? Cubed, so negative 3 cubed is what? Negative 27. And then next I would need to multiply these two things, right? So negative 4 times negative 3. Positive 12. Plus 10. And so that gives me what? Negative 5.
I forgot to put a negative sign by it.
That will make a little bit of a difference. Just a little bit. All right, so then the next type of problem is to simplify. Okay, so add like terms, combine like terms is essentially what's happening here. So let's see, 26. Y squared plus 2y plus 3y squared. All right, so what can I combine here? The y squared, so that gives me what? 4y squared plus 2y. Really hard, right? All right, 30. We've got 10, and then in parentheses, n squared plus n. And then outside of that, we've got minus 6 times in parentheses, n squared minus 2. All right, so with this one, what would distribute? So that gives me what?
10n squared plus 10n minus 6n2 squared plus 12.
Plus 12. All right, and then am I done?
Combine like term.
Okay, combine like terms, so that gives me what?
4n squared plus 10n plus 12.
And now we're done. Trying to watch the time to make sure y'all have plenty of time to work on this stuff.
Doesn't chapel like make the class shorter?
It does, but class ends later, so we end at 46. 10:46. Let's see. Next type of problems, evaluate the expression for the given values of x and y. So it's going back to the problems we were doing, but now they're giving you two variable values, and we got to plug them both in. So let's see, 40. We've got 3x squared, 3x, all of that squared, minus y cubed when x equals 4 and y is equal to 5. All right, so we're going to plug in 4 for x and 5 for y. So I've got in parentheses 3 times 4, all that squared, minus. Now this is important. This minus sign is not inside being cubed, so I'm going to leave it out. Okay, so the y, so 5 being cubed. Okay, so it doesn't make it negative 5 cubed. Now, because it was an odd power, if you had messed up and put it together, it wouldn't have made a difference in this particular case. But if it was an even power, it would make a difference in your answer. So this is why I like to put the parentheses around the numbers when I plug them in. So I've got 3 times 4, which is 12. 12 squared is?
144.
Okay, 144. Minus 5 cubed is? 125. And that gives me what? 19. All right, I'll let you guys try this next one again on your own. So 42 is x plus 2y over 4x minus y when x is equal to negative 3 and y is equal to 4. Do we have an answer yet? Okay, yeah. Alright, so that gives us negative 3 plus 8 on top over negative 12 minus 4. So on top, that gives me 5 over negative 16. Okay, the negative sign, it doesn't matter where it goes, so you could write it that way. You could write it as negative 5 over 16, or you could just write it as negative and then 5 over 16. Okay, I don't care where the negative goes as long as you've only got one of them out front somewhere. All of that means the same thing, so if you have any of those options, that's fine.
I messed up. I added this one in the front. I make a lot of mistakes. All the time.
All right, the last little section here says to simplify the expression, so it's kind of back to what we were doing, just combining like terms. It's just given to you with two variables. So we've got p cubed plus 3q squared minus q plus 3p cubed. So what would that give us?
4p cubed plus 3a squared. That's a cube.
I don't know.
Squared minus q.
It's okay. The other day I was trying to, I don't think that was in this class. I think it was in pre-cal. I was trying to teach something and I chose U and V to be the letters that I was using.
Well, you know where that was done.
Yeah, it never ends well. I've done that for now 3 years straight and I haven't learned yet. It's fine. All right, one more. And then I'll give you guys time the rest of class to knock out the problems that I'm assigning. All right, so we have 3 times x squared minus y plus 9 times x squared plus 2y. So what do we need to do first on this one? Distribute, so that gives me what?
3x squared minus 3y plus 9x squared plus 18y.
And now what?
Now you
Combine them terms.
So that gives me what?
15y.
12 x squared minus 15.
Okay, and it doesn't really matter if you chose to put the y's before the x's. It really doesn't matter. Typically, we want them in alphabetical order. It just makes it look nicer. It makes it easier for going over answers, checking. Makes it a little easier on me grading. And we always want variable powers in descending order. So if we have like an x squared, an x, and then like just a constant term, we always want to go squared to the first and then constant, okay? It just makes it easier. While it's not technically wrong to do it the other way, it just, like I said, makes life a little simpler. And it'll also make your answers line up with the back of the book. All right, so your classwork problems, okay, if you don't finish them, then obviously you've got to do them for homework. They're due tomorrow. But, I lost my thing. 5, 9, 13, 17, 21, and most of those should go pretty quick. They're just the exponent ones and then the just plugging in one number. Let's see, 25, 29, 37, and 49, and then 51 I'll make a separate tab for. This will be an extra credit problem for 2 points to the first quiz. Okay, so I'll make a separate tab for that one particular problem. Okay.
No. It's gonna be easy.
It's a problem. It says write an algebraic expression that includes 3 coefficients, 2 like terms, and 1 constant term, and then simplify the expression. Okay, you cannot use the sample answer that is in the back of the book. Okay, you have to come up with something on your own.
Can I go get my
calculator?
Yes. Okay, so as long as you don't use the one that's given as the sample answer in the book.
Couldn't we just like follow the same formula for like in the back of the book?
I would like you to at least attempt it without that, but yes, you can. Anyways, but I will have you guys do that again as a separate one. It's just kind of fun. You kind of have to write your own math problem. So.